Co-teaching. One teach, one observe. You are now watching an example of co-teaching. One teach, one assist. This is a 6th grade science class in which students will be filling out guided notes as they follow along in a PowerPoint on energy and heat. This is a collaboration setting in which there are regular education students as well as special education students.
There's a few questions within here, and then at the end, we'll cut them out and put them in your book. So don't fool with that while we're taking notes, okay? Alright, obviously we're talking about energy. Does everybody have notes? Yes? Alright. I can statement. Somebody read the first one. Raise your hand. Mackenzie. Okay, I can describe the convergence between potential and kinetic energy. That's one thing you should be able to do by the time we get through the energy notes. Chase?
I can set the law of conservation of energy in my words.
Okay, I can set the law of conservation of energy in my own words. When we get to that part of the slideshow, it's going to get repetitive. Okay, I'm going to make you guys say it over and over. I did last class, and I bet if you picked one of them out of that class, they could tell you what the law of conservation of energy is. Okay, that's how you memorize. All right, it'll get repetitive. So these are the two things we're taking notes on: energy and heat.
As you can see, one teacher predominantly teaches the lesson, while the other will circulate throughout the room to assist students when they are in need.
Potential and kinetic energy. When a skier skis down a hill, potential energy is transformed to kinetic energy. Kinetic energy also can be transformed into potential energy. Suppose you throw a ball straight up into the air. The muscles in your body cause the ball to move upward when it leaves your hands. As the ball gets higher and higher, its potential energy is increasing. At the same time, the ball is slowing down and its kinetic energy is decreasing. Fill in your blanks. Alright, what is potential energy? Ben?
Energy that is stored and not being used.
Energy that is stored and not being used. So what would an object with potential energy look like? Lace?
Like right before you're fixing to throw a ball.
Right before you're fixing to throw a ball.
As you can see, the co-teacher not only circulates the room assisting students with the content, but she also assists them with anything else they may need.
An object that's moving. Okay. So, in this example, I couldn't find a ball. So we're going to use this eraser. You got a ball? Okay.
Not only is the co-teacher assisting students, but the other teacher as well.
Alright, here's our ball. Stress ball. Okay? Suppose you throw a ball straight up into the air. I want somebody to watch this, okay? And you're going to describe to me where there's potential energy, where there's kinetic energy. Okay? Here's where I'm starting. Throw. Okay, what's it at here?
Potential.
Potential, because it's still. And then what? Kinetic. Is there anything in between?
Yeah. Potential. Yeah.
There is. William where?
In the middle?
In the middle. Okay, so if I'm here, you're saying this is the middle?
No.
Okay. Then where else is there potential energy, Chase?
Your hand is fixing to catch the ball.
My hand is potential, yes, because my hand's not moving, but we're just talking about the ball. Paxton, you got an idea? Sure? We can talk through it. Okay. Tyson?
Gravity?
Gravity might have something to do with it. Okay, watch again. All right? Here's potential. Kinetic. There's potential again. Is there anything else in between there, Paxton?
Kinetic when it's slowing down.
Kinetic means it's moving, right? Okay, so you're right. It's kinetic when it's coming back down. What about that split second when it's right here?
Oh, potential.
Potential, okay? We really can't see it, and I forgot my magic stuff at home. I can't make it stop there, okay? But this is potential, okay? Here's slow motion. Potential, kinetic, kinetic, kinetic. Then it changes directions, and for a split second, right here it's still. There's potential again, and then kinetic again, and there's potential. Make sense? Throw it. See if you can see where it stops. I mean, because if it never changed from kinetic to potential, what would happen? It'd keep on going, right? All right. Does everybody? That makes sense to everybody? Yeah.
What you're looking at now are the notes that the students were filling in as we went through the PowerPoint presentation. As you could see from the demo, the co-teacher not only circulated the room to help the special education students, but she circulated to help any student and took note of the ones who needed more assistance and stopped by their tables more often. This is a copy of the lesson plan that was used for this lesson that you just watched. Each teacher had very specific roles. One teacher had the role of lead teacher, going over the PowerPoint and directing students and fostering discussion. The other teacher was to circulate the room and assist students in need.